So the title of my talk here is Preparing to Adapt, but I think really a better title for this should be, and what I'd like to speak about today, is the issue of when to adapt. So I know that we are all here at a conference about adaptation, but I thought it might be good to sort of put a couple of definitions up at the top just so that we're all on the same page. So adaptation, as we were discussing here, refers to the changes that might be made to the sort of climate and increased weather variability. And we may make changes both to the direct impacts of increased precipitation or temperatures, but also to the indirect effects, such as increased weed pressure or pests that may come about as well. So that's what the direct and indirect refers to there. And I just sort of arbitrarily divided the changes into sort of two categories. One is sort of practices, how you go about the business of farming, both the in-field practices, the financial decisions, how you make decisions, but also the sort of bigger issues when you're making investments. Are you sort of putting in an orchard? Are you buying new equipment? We're not really focusing on mitigation. That was an early aspect of the climate hubs under the previous administration, but I think as we've already heard, there are a number of sort of adaptation practices which also have the nice co-benefit of reducing various greenhouse gases. So ultimately, when to adapt is a business decision. Basically, what will it cost and what are the benefits that we're going to see? But climate change is really only one of many factors that are already impacting operations. And I think we have to be honest with ourselves. You talk to a farmer and climate change may be third, fourth, fifth, 10th on their priority list. But on the other hand, as we've seen, it's relentless and it's cumulative, and there are aspects of it in terms of variability that can be extremely important in any one year. Another important factor to remember, of course, is that climate change, what's going to happen, it's just riddled with uncertainty here. This is kind of a theoretical diagram about sort of considering climate and non-climatic factors. So on the vertical axis are the significance of climatic factors, in terms of your decision making and what you're going to do. And across the bottom are the significance of non-climate factors. And in many cases, your decisions are going to be dominated by these non-climatic factors. And if that's the case, and if the climate impacts are not large, this is something in a sense that you don't have to worry about. But there are sort of operations and instances where the impact of climate change can be absolutely dominating across agriculture. And the recent drought in 2016 is a great example of that. And no matter what your other problems were, when drought occurs, that's bad. Kind of using this sort of conceptual diagram as just a sort of an idea, I wanted to bring up the idea of over-adapting or under-adapting. And it basically refers to your perception of how important these points are, these climate and non-climatic factors, compared to how important they really are. So if you think the impact of climate change on your operation is more important than it really is, you may be led to sort of over-adapt, which actually means spending money on things that you don't necessarily need to do that. The converse, of course, is you can underestimate what those are and you will under-adapt. And the same thing applies whether you over or underestimate the non-climatic factors. So it's just a sort of, the point is to just consider all of these factors before you make a decision. So ultimately, though, before we can sort of address the question of when to adapt, we just need to identify what the risks are. And I will define risks in just a moment here, but I'd like to note that different climate events basically lead to different risks. The risk from drought is different from the risk of too much rain. Elevated temperature risks are different from the impact of a late frost, a spring frost risk. So any operation needs to prioritize the risks and ultimately calculate what it's going to cost to address that risk. So risk is generally calculated is how likely is an event and how big it is. So up in the left-hand corner, I have the dollar signs. How much is it going to cost? What's the probability that you're going to see a drought? Is it 1 in 10? Is it 1 in 3? And how bad, how much is that going to cost you? And this is another one of these sort of conceptual diagrams here, where basically this is just telling you to focus on the things that have high consequences and of course also have high probability. And you can see just a couple of examples here because these, trying to get I guess the pointer isn't working here. In the upper right corner are the areas that you really need to address. These are the areas that either have a higher risk or a higher probability, and you really want to focus your attention on those. So something like additional rainfall may actually be, the probability of that is already increasing a lot, but the consequences of extra rainfall aren't nearly the same as a lower probability event of drought. So when you're figuring out your risk, which is a combination of how likely and how much it costs, we would suggest that you probably focus on drought. That's ultimately the risk that you might want to mitigate first. But of course, every operation is different, depends upon your soil, depends upon your structure that you already have there. But these are things to think about. One of the issues that we're really missing within this whole field of climate adaptation is how the probabilities are going to change in the future. This is one of the few examples where you can actually see the probabilities of temperature increase across the United States. This is based on the high scenario. And what's really interesting to me is there's essentially no probability that we won't see at least a 2-degree increase. So if you're going to be sort of calculating your risk profile, what you would want to do is you want to calculate basically what the most likely risk is, but you can also, from a diagram like this, figure out what's the maximum risk you're going to sort of look at. In this case, we're talking about an enormous increase of 8 degrees Celsius, but that's a very low probability. That's only about a 5% probability. You can't consider all of these things, but as we move forward into adaptation, this is the kind of information that we're all going to need. And sadly, that's lacking for rainfall right now. Now, based on something like that diagram before about how temperatures are going to change, sort of your risk is the likelihood times the impact. Here's the impact, but the impact depends upon where you are. This is a summary of sort of relative crop yield. This is from Jerry Hatfield, the initial sort of climate director of the Midwest Hub, looking at how yield changes as a function of the mean June temperature for several crops. And what's interesting is if you are, for example, in Bismarck, North Dakota, and it gets a few degrees warmer in June, your yield is likely to go up no matter what you're growing. And of course, the Northeast, in many cases, our yields will go up too as temperatures increase. But if you're in Des Moines or Wichita or Pine Bluff or Kolkata, the new spelling of Calcutta in India, any kind of temperature increase is going to be a disaster. So it depends, again, where you are and what the expectation for your region is. On the rainfall side, this is some recent data from one of our Climate Hub co-directors, Michelle Cavagelli, looking at yield variation in Maryland in corn and soybeans with rainfall. And again, we don't have a probability with us, but in this case, pretty much as I think you all know, no matter what, less rain is not a good thing. There are also a number of uncertainties. Uncertainties often sort of delay decision making. They either mask what the true trends are or they confuse the sort of cognitive process But there are a number of uncertainties that all of us face. We don't know how fast greenhouse gases are going to increase. We talk about these different scenarios, these RCP 4.5 or RCP 8.5, and these scenarios are based on sort of these future emissions of greenhouse gases, which none of us have any idea exactly how they're going to go. This is something that society as a whole, the world as a whole, is responsible for. And it is also something that human behavior can change. But I will say, I think in the short term, we're pretty sure that society as it is and our use of fossil fuels and other things are not going to change. So we're pretty sure that we are on these sort of trajectories, at least for the next 10 or 20 years or so. Additional questions, of course, is how do these increases actually propagate through to changing our climate and weather? And how will all these other sort of climate factors change? Okay, so at this point, it's a little hard to sort of see things when you're standing quite so close. But the basic question is, it's very difficult at this moment to estimate risk in this sort of economic or probabilistic way that I just mentioned, even though it's a place that we want to go. So the question is, what do you do when we can't really do that at this point? And I think the solution is to kind of look for the low-hanging fruit, look for these win-win situations or no-regret options, or even limited or low-regret options. And I think you can read the details of those. But there are many options, or at least some options, these win-win options such as cover crops and soil health, which are good for an operation no matter what happens to the climate and will increase your resilience to a climate change. So there's an adaptation we can all get behind, and we can get behind those sorts of adaptations now. There are other sort of low-cost sort of adaptations which are already used widely to deal with current weather variability. Perfect examples are either irrigation or tile drainage, as Dave mentioned. And again, I think what we need to do is examine the economic cases for those, and the way the weather is going, anything that's useful now will likely be more useful in the future. And the same applies to these slightly more expensive, low-regret solutions. So the key priorities, really, as I finish up here, I don't want to keep us from our coffee any longer, is ultimately we want to be able to estimate the risks for the various aspects of climate change and weather variability. These risks will be different, whether we're talking about drought or too much rain or frost or whatever it is. We want to prioritize these and sort of do a cost-benefit analysis on this. How much is it going to cost, and how much are we going to benefit? And so things like case studies, sort of whole farm budgets, these sorts of things. We definitely want to focus initially on the win-win and no regrets options. And I think, in the long term, I don't know who it was, but somebody said in the long term we're all going to be dead. So let's focus on the short term, and that's what makes the most economic sense too. So thank you very much, and thanks for being here. We really appreciate it.
Good morning, I'm Jen Dininger with Maryland Sea Grant Extension. I have a question about your no regret solutions. The downstream living resources might have some regrets about increased drainage, and I think David's presentation also alluded to irrigation practices not all working during the drought of 2016 as well. And so I think when we do cost benefit, we need to look a little broader than just the on-farm operation and the costs and benefits to those operations, because groundwater depletion certainly would not be a no regret.
Absolutely. And some of the calculations change if it's a shared resource. In fact, if that's the case, it sort of speeds up when adaptation should be done, when people have sort of carried out those analyses. And it's true, we don't want anybody to be a bad neighbor in terms of putting in, increasing nutrient problems that may already exist. So In my 10 minutes, I was probably a little fast through some of these things, but I think these are things that many people are doing now. Undoubtedly, will continue to increase throughout the Northeast. But you're absolutely right. We have to sort of watch that there aren't these sort of unintended social consequences or consequences to the rest of us from individual actions. Yeah, thanks.
Hi, my question is soil pH. Are we expecting any trend in soil pH change, or do we need to follow any adaptation methods according to that? Any change, any trends in soil pH change that we'll be expecting with the climate change?
If I caught the question correctly, was it soil pH change that you were asking about? I'm not a soil scientist, so that's an easy out for me, but I do think that soil health is, and various aspects of that, which will relate to your question, are probably some of the easiest, the lowest hanging fruit, the win-win situations that we want, and how you get about building up your organic matter and improving your soils will help you resist almost all aspects of the climate change as we've heard that it's expected in the Northeast.
Hi Dave, thank you for your presentation. I just wanted to mention something about the less than 20 years focus. Yesterday morning in STAC meeting, Scientific Technical Advisory Committee of Chesapeake Bay. And one of the things, in fact, when they worked into the Chesapeake watershed model that EPA, Chesapeake Liaison Office is simulating, was pounds of nitrogen and phosphorus that each jurisdiction within the Chesapeake watershed should reduce to meet the TMDLs by 2025. Well, of course, their projections of future doesn't really rely on climate models, but rather it is a projection of the historical climate that they input into the model. And so, having said that, what happened was, in fact, New York and as well as Delaware, according to what they showed, both of them are being asked now to reduce more nitrogen and phosphorus as a result of the climate impact. And so, and that is a policy issue because that's creating problem, and these states are saying that, oh, you all told us if we implement these BMPs, we'll be okay by 2025. What are you telling me that we have to reduce more? That means, what are we going to do about that? There is an economic and policy. So while I agree with you with some of the things, but we need to be cautious about the overall, in other words, regional impacts and water quality and these major water systems that are, nowadays we have to meet the TMDL requirements and so forth. That was something that caught my eye. But from planting system, probably that's a good target. Thank you.
Yeah, I appreciate that very much. So thank you.